Alright, so talk briefly about throwing and dropping objects in their position function. We've also talked, we talked a little bit about particle shopping along the axis a little bit. Alright, this is where we're going to do sort of more of a formal discussion of particle motion. And when taking the AP test, you're going to definitely see multiple problems that talk about particle moving along the x-axis, particle moving along vertical axis, horizontal axis, that type of stuff. Alright, so in order to talk about this, what we need to make sure that we have is we need to make sure to remember that position. Okay, position is we typically are going to see it represented as S of T. Alright, it's our position. Okay, our velocity function is the velocity function is the first derivative of the position function. So the velocity function we represent it as prime of t, or just t. Okay. But what you want, the big thing that you want to make sure that you remember is that velocity is the first derivative of position. Now, speed. You remember what we know about speed? It is what of velocity? Absolute value. Alright, so velocity can have a positive or a negative sign. Alright? Negative telling you that it's moving in the negative direction, so it's either left or down. Alright, depending on which axis the particle is moving. If it's moving on the vertical, the y-axis, if it goes down, it's negative. If it moves on the horizontal axis, it's going to be moving left. Alright, now speed does not have a direction associated with it, so it is the absolute value of v of t, which is also equal to the absolute value of s prime of t. Right. So, remember that. The next thing that we know, we haven't talked too much about this, is acceleration. Alright? So acceleration is equal to, we represent it as a of t. It's equal to the first derivative of velocity, so v prime of t. And it's also equal to the second derivative of position as double prime of t. Alright? Now, along with that, you're going to have this new term. Alright? And did you guys take physics last year? Alright, so you guys remember displacement? You know what that means? Yeah, well, so you're displaced, there are two things. You have displacement and you have your total distance. Alright? Displacement is the change in position. Change in position. And what that means is this. Let's say I'm standing at the origin right now. Alright? And let's say I'm standing right here at the origin. Alright? And I walk 4 feet that way. Alright, that's 4. And then I come back, I need to come back this way, say 2 feet. Alright? My displacement would be 2 feet. Because I went 4 feet, because I came back 2 feet, so my distance from the origin is 2. Alright? Now, the change in position can be figured out. So if we're looking for an equation for that, the change in position can be written or displacement. The way you can find that is you can say it's equal to S of V minus S of A. So you take your final position and you subtract from that your initial position. Alright? Now, we're talking about total distance traveled. Our total distance traveled would be 4 plus 2, which would be 6. Okay? So, what do you think about that? So So that's just sort of a pressure displacement. Just remember, the position at point B minus the position at point A. Okay. So, here's some things that we need to make sure you have written down. When our velocity is greater than 0, all right, the position function is increasing. We know that the particle is moving right or up, based on, depending on which axis it's on. All right? So when v of t is greater than 0, the position function is increasing. And the particle is moving right or it's moving up, based on which direction we're talking about. When velocity is less than 0, the position function is decreasing. Particle is moving left or down. And when the velocity is equal to 0, position function has a maximum, minimum, or shelf. And what that means is that the particle is at rest, or, okay, so the particle is going to be at rest, and it may or may not be changing position, or changing direction. So when the velocity is equal to 0, that tells us that the particle is at rest, and it also lets us know, okay, at this point, this particle may or may not be changing direction. All right. Now, all of this should sort of make some sense because we said velocity is our first derivative of the position function. And we know that when our first derivative is positive, all right, and when our first derivative is greater than 0, that tells us that our function is increasing. So we're essentially taking what we've been talking about and applying it to this idea of particle motion. Okay? What we're going to do, we're going to look at a couple of examples. And, yeah, we may have some time to work on some homework in class. But what we want to do is we want to go take a function, take a graph of that function, and begin to answer questions about how a particle is and what's going on with this particle. So, it says a particle moves along a horizontal axis. And we do the method. Its distance from the origin is shown. Okay. When the particle, okay, so the first question we'll ask is, or answer is, when is the particle moving to the right, to the left, or standing still? All right. So this particle is going to be moving to the right. Okay, so let's think about this. When it's standing still. 2 to 3. Yes. Okay, so what we want to do here is couple. All right. So first of all, we can figure out. We know. We just wrote down. All right. All right. So the position function is increasing when. Okay. So the position function is increasing. When velocity is greater than 0, the position function is increasing, which means that moving particle. All right. So our velocity is our first derivative, or the slope of our position function. So what we want to look for here is, when is our position function, when does it have a positive slope? So when is the slope of this function positive? So from 0 to, my slope is, that's a positive slope right here. Alright? That means that it's moving to the right. from 2 to 4, or 2 to 3, that function has a slope of 0 because it is, or has a slope of 0, which means that position, or that particle is at rest. So here, we say that when v of t, when the velocity is equal to 0, or when the slope is equal to 0, the position function has a maximum shelf and the particle is at rest. So, we know that here, the slope is equal to 0. Okay? Now, from 3 to 4, we have a negative slope. And from 4 to 6, we also have a negative slope. Alright, so from 3 to 4 and from 4 to 6, this function is moving which direction? Left. Alright? So, when is the particle moving to the right? Well, it's moving to the right when the slope is positive. So from 0 to 2. Alright? So, right, that's going to be from t equals 0 to t equals 2. And actually, a better way to write that would be 0, 2. Alright? Now, what do we do with that? Well, we just say whenever the slope is negative for the position function, that tells us that we're moving to the left. As we move to the left, we move to 6. I'm not going to bracket because at 3, it's not defined there. It's not differentiable, so we can't really do that. There's still a corner. So, 3 is like in between where it's like at 2 to 3. It's like at slope of 0, but also slope of negative. So it's not differentiable. Therefore, there's no vertical value. And then standing still, 2 to 3. Actually, yeah, we can right there. 3. Alright? Questions about that? Alright. So, what we want to do now is we want to graph the velocity and the speed. Okay? So, we will go ahead and first off, so in order to graph the velocity function and the speed function is easy. We just have to make sure everything's positive in the velocity function. Velocity function, we need to know the actual what of these parts of each function. In order to graph the velocity function, we need to know what of each. So we need to know the derivative of the position function. Or we need to know the slope of each part of the position. So, can we quickly find out the slope? Well, yes, because first off, we have right here, this is a positive slope, so we're going up 2 over 2. So if we go up 2 over 2, that's going to be a slope of what? 1. So our slope here is positive 1. We know that's 0. And then we have, so we're going to go down 4 over 1. We went down 4 over, or actually we went down 5 over 1. That's going to be negative 5. Alright? And this is down 2, down 1 over 2. That's a negative 1/2. So you know our slopes. 1, 0, negative 5, and negative 1/2. So I'm going to create my axis. So, let's look at this. So we know the highest slope I have is 1, the lowest slope I have is negative 5, and we go from t equals 0 to t equals 6. So, first of all, let's put in our our lines here. 0, 1, 2, 3, 4, 5, 6, 1. We have negative 1, 2, 2, 3, 5. Alright. So go here. From 0 to 2, there's a 1. Alright, so 0, 2, 1. Makes sense? From 2 to 3, there's a 0. Yeah. Just have to be right on the dash line next to it. Then we go to 3 to 4 to negative 5. And then from 4 to 6 is negative 1/2. That. Right? So we went ahead and do that. Now, we want to now get the speed function. Alright, the speed function is, we know the relationship between speed and velocity is what? Speed is absolute value. So, what are we going to do with each of these parts of this graph that have negative velocity function, or negative velocity function? There's just a number to the top. Alright, so we would take and I put that in the wrong spot. There, that goes there. Now we're going to graph the speed function. Again, now my axis will look a little different because, you know, we don't have any negative values. So again, we need 0 to 6 and 0, 1, 2, 3, 4, 5, 6. I'm just going to go ahead and take this and one, of course. So we're going to start over. We have 1, 2, 3, 4, 5. Alright, so we know that it is positive 1 from 0 to 2. What? Oh, never. It is 0 from 2 to 3. Is right there. Alright, from 3 to 4, we got positive 5. That's no also, you know what else. And then we're at negative 1/2, so that's going to change to positive 1/2. So that's going to be like right there. Questions? Alright, now, guys, now let's find the particle displacement over 0 to 6. Alright, remember we said that displacement is equal to S of B minus S of A. So the final position minus the initial position. So, I'm going to come over here, look at this. What is our initial position? And what y value do we initially start at? 2. So our initial, so S of B, or no, S of A is equal to 2. What was our final position? Negative 2. So S of B equals negative 2. Okay. So we want to find the particle displacement. Particle displacement is going to be S of B minus S of A, which is equal to S of 6 minus S of 0, which is equal to that negative 2 minus 2, which is equal to negative 4. Okay. S of B was negative 2. Oh, it should be negative 2 minus negative 2. Huh? Because it's minus negative 2. Oh, yeah, sure.
Yeah.
Alright, so we're good then. Now to find total distance. Alright? Right now what we're gonna have to do is we're gonna have to just look at this and total distance, we're gonna try to figure out how far this person traveled, not taking into account about how far we are from Florida. So total distance, easy way to do this is to sort of make a table. Alright? And what we're going to do is we're going to look at each of the major points that we have. So, from here to here, how far is this part of the travel? 2 to 4. It's travel to 2. Alright. So, what we're going to do, we'll actually go to even. Here's what we do. So at t equals 0, this position was 2. Alright. At t equals 2, position was 4. At t equals 3, position was 4. At t equals 4, it was negative 1. And at 6, it was negative 2. Alright? So, that's the distance of 2. That's the distance of 0. Just find the distance between these. This is the distance of 5. You have to go from 4 to 0, which is 4 spaces. Then 1 to 0. So that's 5. This is the distance of 1. Alright, so find the distance. 2 plus 5 is 7, plus 1 is 8. So it's 8. This is the total distance shot. So, alright, so here's what we're now at. It says particle travels along a vertical axis, it goes up and down. Its position is shown in the graph y of t. Okay. Now this one's a little bit trickier because it's not straight lines. Alright? So it's not like constant speed. Well, that's fine. So first off it says what is the displacement of the particle over 0 to 10. The equation for displacement is what? So S of B minus S of A, where B is your final time, A is your initial time. So it says over 0 to 10, so we're finding S of 10 minus S of 0. So, S of 10 we have to look at. Well, do this. So we can go 1, 2, 3, 4, 5. Alright, so S of B is 5 minus S of A, which was -1, equals 6. So that's our displacement. Make sense?
Yeah.
Alright. So now it says, what is the total distance traveled by the particle from 0 to 10? Alright, so total distance, yeah, make some sort of estimation for it. So from here, and so the thing to do is you want to get the max, like, points that you know into like the max. And then, so from here to here, alright? So it traveled 1, 2, 3, 4 spaces. Alright, so that's the distance of 4. Alright? From here to, let's say, to here. Alright? It went up 4 and then up 3 more, which would be 7. Alright? Then we have from here to here.
Wait a minute,
What?
is that dot from 5 or 2 or 3?
Here?
Yeah.
That dot is on the bottom.
No, the 2 or 3 wires.
Estimation. Doesn't mean you look.
Fine.
I think it'd be like maybe in the middle. So we could be, I mean, you can get technical here.
Okay.
You want to get technical?
No.
Alright. So we'll say it's at 3, so that's 7. From here down to here, that'd be a distance of 3. From here up to here, that'd be a distance of 5. So add the numbers equal this.
So it would never be like negative, like.
The whole distance will never be negative, because you can't travel negative, right? So we have, you know, 4, 3. Oh, yep. Well, I thought that was 5. So, no. So, 8. So, 4 plus 8 is 12, 15, 20. Our total distance traveled by the particle from 0 to 10 is 20. Alright. Make sense so far?
Yeah.
Alright. So, when is the particle moving up, down, staying still, at rest? Okay? So, all we have to look at right now is the graph. Alright? What? I know. So, how do we figure out if this graph is moving up, or if this particle is moving up?
What is this for?
What is it looking at? 2 to 5, that graph would be, or that particle would be moving up. Why?
It's like, well, from the negative side over the positive side.
So the slope is what? So we know that when we know that the slope of this function, which is this position function, so the slope in the first derivative. So we know that when the slope is positive, the velocity is positive, and back there we know that when the velocity is positive, the function is moving in a positive direction. Yes. So from 2 to 5, 7 to 10. Okay, so moving up to be 2 to 5 and 7 to 10. So, here, when is this function be moving down? Right, well, not when is this part be moving down?
We kind of had like 0 to 1.
You're looking at the y value, you're looking at
I'm looking at the.
you're looking at
Oh, wait, negative 1.
They're not moving only what t dot, what x I?
0.
0 to what? So yeah, so this function is decreasing from 0 to 4, or 0 to 2. So that means that it has a negative slope. And this velocity is negative, so the velocity is negative, and this is 0 to 0. Alright? So moving down. So from 0 to 2, it's moving down. Anywhere else that's moving down?
5 to 7.
5 to 7. Alright. So down the 0 to 2. And 5 to 7. Alright.
Now, for standing still, when it's like, which one, the max and stuff?
That's the name, because standing still when the velocity is 0, so where the slope would be 0. So, yeah, so standing still, that rest would be here, t equals 2, t equals 5, t equals 7. So, t equals 2, t equals 5, t equals. So, we also need to figure out what is the average velocity of the particle. Okay? So, if you look at this, so first of all, we haven't really given us a solid function for average velocity, but we do have it. And the average velocity, average means slope. So we know if we're looking for the average rate of change, we do f of b minus f of a divided by b minus a. Right? And this asking what is the average velocity of the particle. So average is that's telling us we want slope. Alright? And we want this, so we want the average slope, alright, of the position function. Alright? So we want, because if you think about it, velocity is going to be distance over time. Well, if we do this, it's going to be f of b minus f of a divided by b minus a, where f of b and f of a are distance, and b minus a is time. Okay? So what we're going to do, we want to know the average velocity from here to here. Well, that creates a line right there. So we want to know the slope of that line. Okay? So we know B, A is 0 and B is 10. So we're going to have f of 10 minus f of 0 divided by 10 minus 0. Okay? So we know f of 10 is 5. We know f of a, or f of 0 is negative 1. We have 5 minus negative 1 by 10. 6 over 10. Alright. Alright. So our final question is, when does the particle first reach the origin? Alright, again, we can look at the graph. So when does the particle first reach the origin? So what does that mean in this? Exactly. So what that is, where does this function first reach a distance of 0 from the origin? So it'll be t equals 4. Right? Because right here, it's not at the origin, it's at 0, negative 1. So the distance will be 1 away from the origin. Alright? And you come here, you get further away from the origin, further away from the origin. Now you want to go back closer, 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 and then you have the origin. Now you move away from the origin again. Now you come back towards the origin. You get to the origin, and then you start moving away from the origin. Alright? So that's going to be right? Question mark. you say? Yes. Alright, so a particle travels along the horizontal axis. The graph is velocity, v of t, is shown in the graph below. Okay. So, this case is, we don't, first of all, this one is, we are given the graph of velocity, this is our conclusion about the particle for the position function based on this. So it says, when is the particle moving to the right? Well, we know that the particle is moving to the right when our velocity is greater than 0. So where is our function? Where is this velocity positive on this function? Okay. This is not our position function. This is our velocity. So the question is, when is the particle moving to the right? We know that particle is moving right or up when the velocity function is positive. Right? Is our velocity function positive right here? Everyone gets positive. Okay. So right here, our velocity is positive, which means that our particle is moving to the right. Stay positive. So it's moving right. Still moving to the right, still moving to the right, still moving to the right, still moving to the right. And right here, stops. And it becomes negative, which means that starting at t equals 5, it's now starting to move to the left. Alright, so from here to there is moving to the right. So from 1 to 5, our function is moving to the right. Then starts moving to the left, and then right here, it starts moving to the right again because our velocity is not positive, equals 1. So we need 9 to 2. I guess we say 9 and 10. 10. So it's moving to the left. To the left, this is when our velocity function is less than 0. So when is our velocity less than 0? Well, it's less than 0 from 5 to 9. So we move left from 9. Oh yeah. And from 0 to 1. So 0 to 1, 3, 5, 9. Okay. Now, then asks where is that rest? Well, where is our function is at our particle is at rest when our velocity is equal to 0? When is our velocity? Velocity is equal to 0, so it's going to be t equals 1 is at rest, t equals 5 is at rest, and t equals 9 is at rest. Okay? So again, all we're doing is we're using our derivative, the function of our derivative, to figure stuff out about our answer. Figure stuff out about our position function. Okay? Also asking the particle moving the fastest. When is the particle moving the fastest?
No,
Yeah, the thing is too hard here. When is it moving the fastest? This graph right here is the graph of what? The velocity, right? Where is the velocity the greatest? X equals 3. The greatest value of velocity is right here. It's the highest velocity. So, using the fastest path, that's the street. Makes sense? Alright. Alright. I'm gonna come back to this tomorrow. We're gonna finish this on